Welcome to another episode of the Distributed Data Show, brought to you by DataStax Academy, where we bring you the latest news and interview technical experts to help you succeed in building large-scale distributed systems.
Hello everyone, and welcome to a special Halloween edition of the Distributed Data Show. We will clearly be doing dad jokes and kind of creepy sound effects for this entire show.
Maniacal laughs.
Yeah. So I am joined in the studio here in San Francisco by Patrick McFadin. Hello, Patrick.
Hello, Luke. It's good to see you in your embodied form.
Yes, it's good to be here. I'm wearing my Bengals shirt in honor of what a horror story I'm sure the Bengals season is.
Scary story.
Is that a dad joke?
It was kind of a dad joke. I'm also joined in the studio by Jeff Carpenter. Hello, Jeff.
Hey, how are you?
I am doing wonderful. So we thought it would be fun in honor of Halloween to maybe tell some Cassandra horror stories, some Cassandra data modeling horror stories, something along those lines. And I don't know, maybe we should kind of throw a little bit of a disclaimer out there first.
This is not suitable for scared children or DBAs. Because both will be scared out of their wits.
Oh my goodness, yeah, they won't stay in bed. They keep coming into your room and waking you up. Oh man,
yeah.
Okay.
Not bad.
Yeah. So I was thinking disclaimer along the lines of we are, we share these kind of things. Like sometimes these are fun stories to share. Just not only mistakes that we've seen other people make, but also mistakes we personally have made. Believe it or not, we are fallible.
Plenty of times, right?
Yes. Constant learners. So none of this is meant in any sort of a mean-spirited fashion or anything like that. This is it's kind of actually a really good tool when you can, we tell people a lot of times, this is what you should do, this is how you should do it, but sometimes it can be instructive too to say, hey, this is what you shouldn't do. This is some common sort of stuff, anti-patterns that we've seen.
And how exactly did we figure out that you shouldn't do it that way?
That's usually the case, is you don't know just theoretically the bad thing that you can do until you see it.
Yeah.
And you're like, oh, that's a bad idea.
Yep.
And experience is that, right? Experience, the teacher of experience, is harsh. So harsh. It's a horror story, really.
Yes. Okay, so Jeff, I think you're going to start us out. Tell us a scary campfire Cassandra horror story.
Nice. Well, one of the great features of Cassandra that allows you to kind of take advantage of this denormalized design and get a really wide row is the use of collections. So I encountered a case where there was one particular, let's say, consumer of this data model, and this was a data model that was being used to store pricing information. So not understanding how every single hotel is going to price their rooms, there's a particular group of hotels that created a different price for every possible combination of things, day of the week, let's say, discount levels. And so pretty soon, if I have a collection where I'm using to store all these rates differentiated by different criteria, I have an explosion.
How many combinations of things were there here? How many collection items?
We're not in the millions. It wasn't as if that we were sort of hitting the theoretical limit of the collection size. It was more like, hey, I keep getting these large batch warnings in the log. What does this mean?
I'm actually responsible for that. I wrote that.
The JIRA, they put the warning in for large batches.
And the failing of a batch, because, and this is just a very common story, it was for a long time, especially back in Cassandra 1.1, 1.2, is hey, batch seems like a great idea because and I think to no fault, I did the same thing. No fault of anyone, is because they worked really good in a relational database because you're in one server. A batch works really good in there. But man, you throw a batch at a distributed system, it's a different problem, and it'll just blow up in your face.
Yeah, the moral of the story for me on that one was, anytime you have a situation where there's flexibility in terms of different people are going to interpret your data model in different ways, and they may decide to kind of throw something in a way that you didn't expect, how are you going to stay in front of that and be able to detect it? That's a bit of a challenge.
Yep.
Huge problem. Yeah.
So I have a similar, this is probably a good segue because you talked about batches, and so I have a kind of similar story to that where it's a sort of a batch horror story where I was working with some customers, and one thing that I've seen, and I'm thinking of one instance in particular, we were working on sort of a time series data model where there was it was sort of the classic time series case where there would be this big batch of records, basically multiple records in a single second, and they might get 60 seconds or 120 seconds worth of this time series data kind of streaming into the system. And they were kind of investigating using Cassandra and wanted to do a proof of concept. And so they wrote just some kind of simple early on code, and they were running this. They had test data where they had these kind of millions of points that they would get, or hundreds of thousands of points that they would get within a single minute or two of data, and they were kind of looping over this data. And every time that they would loop over this piece of data to put it into Cassandra, they were doing an execute with our driver, and this was execute like the synchronous execute method, right? So basically, if any of you have used our drivers before, you'll know that we have synchronous and asynchronous versions I think in all the languages.
Except for Node. Node has no.
No, it does. It does. Node has asynchronous, has promise returning and callback methods. So they were basically doing a single call, blocking the thread to execute a record at a time, and then would loop and take the next data point and stuff it in and whatnot. And and of course the question was, well, man, this is really slow. Like, why is this? Like, I thought you said Cassandra was like really good at ingesting data, kind of thing. And so as we're kind of trying to walk through the code and figure out what's kind of what was going on, they at the same time sort of discovered, oh, there's batching. And most people's reaction, if you come from a relational world, is, well, yeah, that's exactly what I should use because I've got all these data points. I've got this big chunk of data.
Why didn't you say so before?
Right. Why didn't you just say we should use batches, right? and so then it was, okay, loop through the records, collect them into batches, and we'll make the batch size configurable so we can try and find out sort of what the optimum batch size is that works well with the cluster. And but again, execute sync the whole time. So it would basically do a whole batch, execute sync, wait. So now you're waiting on this huge chunk of records to come over. And yeah, that helped. But as you're looking at sort of the metrics over on the Cassandra side, you'd see the Cassandra node, because this was only just on it. They were only just testing on a single node at this point. You'd see it do this like a wave, like it'd do a waveform where all of a sudden it'd get this huge chunk of work to do, and and then go down to almost nothing. And so finally, after some cajoling and whatnot, we started talking about the async APIs, and they still wanted to use batches, which actually it was okay in this case. A lot of times we say that that batching is an anti-pattern for loading data. In this case, because of their data model, all of the data, like the batches of data, were for a single partition.
That's a good use case.
And so this is one where they could actually, because all the data that was in the batch was for a single partition, they could use unlogged batches, which is sort of like the use case for unlogged batches. But then we got them to start using the async API and try to get the system, and this was really key, like you want to get the system to a steady state so you don't have this wave of, you're just crushing your Cassandra server with batch after, you kind of want to have a bunch of these in flight at once and figure out, okay, what's, how many of these in flight at once can I have going, kind of thing. But man, it took us a while to get there. And, the batch thing, like, particularly once we made it configurable, it was like, well, let's try 5,000 or 10,000, data points in a single batch. And then of course your warning started showing up.
My warning.
We're like, what does this mean? Why is it telling me the batch is too large?
That's the little guidepost that says don't drive off a cliff.
Yeah.
Like I had to tell you, don't drive off a cliff. There's the sign.
So it sounds like sometimes the bottleneck is your data model, and sometimes it's your threading model.
Yeah. And I think the takeaway for me would be, well, really two things. So one, there is actually like a legit use case for using batches when you've got big chunks of data, and that is unlogged batches when everything's going to a single partition. And then also, you want to, especially when you're in these scenarios where you're bulk loading a bunch of data, you want to try and get it to a steady state. You don't want to be sending over just dumping a big batch, wait for that to finish, another big batch, because if you're going to maximize throughput, you want to have multiple of these in flight at one time. So take advantage of those async APIs. Most of the time, most of the code, at least in my experience that I've ever written, is almost always using the async APIs. Like I haven't really seen a great use case for why you would want to use the synchronous APIs.
Oh, async is the best.
Yep.
It is the secret sauce.
Yep.
If you use async, you'll be pretty happy. And I bet you after that it was Holland, wasn't it?
It was.
Yeah.
And you know what? The async experience, I just want to throw this out there to troll you Java folks a little bit, but the async experience is a little bit better depending on what...
Never miss
I was about to stand up for synchronous, and now I'm shamed.
Depending on what language you're using, like that can be better experience, So like
what would be a great language?
C# actually has a
really?
great... And actually,
surprised.
new versions of Node.js also got the async and await keywords, which are which make writing that imperative style of async code it's a lot better than callback hell is what we used to call it in
callback hell. Yeah, I know that one.
Yeah. So
moving on.
Hell. Callback hell.
Callback hell. We need like some flames behind us.
That kind of sounds spooky, right?
It does sound pretty spooky for Halloween. That's not bad. There's a trick and a treat.
Yes.
So I was going to talk about that time that I was helping somebody that made the decision to upload their entire relational database model from, I think it was MySQL. They just took it verbatim, changed the type so that it wouldn't blow up when it loaded the data model, threw it all into Cassandra, minus the foreign key constraints and anything else, indexing, just basic data model, all the tables, which required joins to work because it was a relational data model. So their solution was to do all that in the application. I'm not.
But you're not going to talk about that.
I'm not going to talk about that story. Okay. No, that is not going to happen here.
This is your way of getting two, isn't it?
Yeah.
Always one.
Not playing by the ground rules here.
Rule breaker.
Go ahead.
All right, fine. So mine is actually something that it prompted a lot of discussions and a lot of webinars and a lot of talks about how to do the primary key properly, and it was pretty innocent use case, and it took me a while to even kind of notice what was going on, but it was this group they had a 6-node cluster, so plenty of power, and they had around a terabyte of data, so not a lot of data.
Yeah.
But
not for 6 nodes.
No, but not for 6
you got
nodes.
A replication factor.
All the math worked out great. It was like, that should fly.
Yep.
But what happened was that they had nodes that were just crashing horribly, and they were really frustrated. And I was thinking, well, maybe there's a hardware problem, maybe there's some setup in the operating system. I was looking way too low down in it. Finally, and this was my own inexperience, is I didn't look at the data model first. When I took a peek at the data model, I realized, the way that the data model was structured was that there were only 4 partition keys.
There were more nodes than partition keys.
There's more nodes than partition keys. And, I mean, it's a perfectly logical mistake to make, but the way that they had done the data model, at first it looked fine, but then when you look at the data that's going to represent, or that's going to be represented by the data model, you realize there's only 4 partition keys. So they had these massive partitions just getting hyperloaded, and I think one of them was like 500 gigs or something. It was really big. And so, and these are in the days, this is like 1.2 days, when CQL is pretty new, and Cassandra's partition sizes were not as good as they are now, or will be with DataStax Enterprise 6. And that, of course, was just a huge problem because it just burned down their nodes. And yeah, after we got through the partition, we did some work with the partition keys, got the clustering column set up right. It worked wonderfully, amazing. So that horror story, luckily, has a nice little end, has the end. So we get the treat at the end.
Right? Was that the silver bullet?
Could have been
Halloween joke.
Yeah. It showed the database vampire the mirror. Look at this.
Exactly.
Oh, wait a minute. It can't see itself, right? I'm blowing all the dad jokes. Sorry.
Yeah.
You're overthinking this.
Picking a partition key is tough, like especially if you're not used to doing it. It can be really hard, or it can be really easy to screw that up. Like I've screwed it up, particularly when dealing with time series stuff and potentially unbounded, potentially unbounded partitions. Like, it can be really easy.
I think that we've all made that mistake.
Yep.
Well, that's like I said, it prompted lots of talks for me. I had a blog post. The primary key is the most important thing you need to know about database or Cassandra data modeling, because that'll make or break it. Everything else is, unless you're using huge collections, but that's another problem. But partition key is so critical for a lot of just understanding, oh, this is what distributes my data around the cluster.
Yep.
That's a really good concept in Grok. Oh, yeah, that's what's going on.
Yeah. Okay, well, gentlemen, thank you for sharing your stories.
Still scared.
This has been fun.
I feel like we could do 3 more episodes on this topic. Should we do that?
If only Halloween came 3 times a year.
Halloween 2018. Stay tuned.
3-part series.
Well, thank you guys, and thank you to everyone who is listening and or watching. We will be back with another terrifying episode of the Distributed Data Show. We will see you next time. Thank you.
Thank you for joining us again for the Distributed Data Show. We love your feedback, so go to the Distributed Data Show page on DataStax Academy and tell us what you think. You can also find us on the DataStax Academy YouTube channel or find our podcast on iTunes, Google Play, or wherever you get great podcasts. While you're there, make sure and subscribe so you don't miss a single episode.